Hello, Krasimir here and welcome to the NodeWorks tutorial. This time you'll learn how to pass any particle attribute or user-defined values directly to Arnold shaders. In this case, we will change shader emission based on the particle velocity. You'll also see how to precisely control particle reflection visibility. These capabilities are enabled by NodeWorks' full integration with Arnold, allowing shaders to access particle data directly without any workarounds or hacks. So I will start the shading setup from the scratch. In this scene, we already have a particle system set up on a spline with a random node controlling particle size distribution. Several forces are applied to make the particles orbit around the sphere, while following the spline path, and the separation node ensures the particles don't overlap. This scene is included in the examples zip file available in the members area, so feel free to explore the setup in more detail. With that in place, let's move directly to the shading setup. First, I need to create a custom channel of type float and name it emit. This channel will store emission values that are directly proportional to the particle velocity. Next, I'm going to add display attributes node. This node will allow us to visualize and read particle speeds that will be used for the particle emission, and of course we're going later to remap them through ramp. Keep in mind that particle speed on the user interface is in units per second, while NodeWorks keep them internally in units per frame, and that is what you access with nodes. So 1 unit on the interface, different units when you handle them through the nodes or through the script. Now we need to get particle velocity and use remap node to remap speed into 0 to 1 range and then feed its output into the custom channel. One of the strengths of the NodeWorks is its automatic type conversion. When you connect a vector output, such as velocity, to a float input pin, NodeWorks automatically converts this vector to its length, which is actually the speed that we need. Otherwise, you need to add another node, like cast, to explicitly convert between vector and float. In this case, the vector length represents the particle speed, which is exactly what we need for driving the shader emission. To visualize this custom value, I will add vertex color node and connect remap output to the input of the vertex color node. Now you can also see the automatic type conversion at work, as one float value will be converted into monochromatic color. Looking at the particle speed values, I think that we can set the speed range between 0.3 and 0.4 to get interesting particle emission. Note, not too many particles that are self-illuminated, but also not too few, so they fall into a nice range. We need to set up the shader and export those particle values into the shader emission channel. Inside the NodeWorks Arnold user data, artists can select which attributes they want to expose to Arnold shaders. So for now, I will select custom channel and choose its Arnold name as FXP speed. You can use any name here, just make sure that there are no duplicates or overlapping names. Now open the Arnold render view, and so we can see what we're doing in shader. Now inside the material editor, I already have the basic standard shader where we'll connect particle properties with the emission channel. First, we need to add Arnold ramp float shader. Change the ramp's input mode to custom and add a user data float shader. In the attribute field, enter FXP speed. Now the shader will read particle FXP speed custom channel and feed it into the ramp as the x-axis value. Each particle will have its own value that we have assigned inside the NodeWorks. So the second key will be set to 10. This means that particles that are moving slower than the defined speed threshold will not emit any light. Once particles exceed the minimum speed, they will start emitting light with intensity controlled by the ramp. Color and final intensity are handled by the shader itself, which keeps the setup flexible, like when you catch particles and want to tweak the look later without resimulating. Now I'm going to set up a simple rule. Particles that are closer than a certain distance to the center of the main sphere will not be visible in its reflections. If I use math node and take position of a particle and position of a central sphere, I will get a vector. The length of the vector is the distance between those two objects. By using the compare node, I can leave the input pin to float and NodeWorks will automatically calculate the length of the vector that is on the input. The result of the compare operator can be true or false at the output. It will be true for all particles that are closer than the user-defined compare value and false otherwise. Based on that output, the Arnold properties node is enabled or disabled, which allows us to precisely apply any operator on a per particle basis. In Arnold properties node, I can change various attributes for specific particles. Now, if I want to control this over time, I can use the const node to animate the value between frames 100 and 200 by gradually removing all spheres from the reflection. You can see in the final animation that spheres are now gradually disappearing from the reflection between frames 100 and 200. Thank you for watching, and I'll see you very soon with new tutorials.